Hey everyone, this is my first video. Today I'm going to show you my first project, which is 3D printing an electric skateboard. So I tried to print as much of it as I could that was reasonably safe and responsible. I'm not going to start printing the trucks, I guess, in plastic materials. But I'll take you in the workshop and show you what I put together. This is a fully 3D printed electric skateboard, printed in nylon plastic but reinforced with carbon fiber tubes, with also a heatsink printed in stainless steel. Essentially, it's fully 3D printed in nylon, done with like a machine called the HP Multi-Jet Fusion 4200. It's similar to SLS in the way that it fuses a plastic powder together, but rather than using a laser like an SLS machine would, it uses a basically inkjet heads that print a pattern in black, a cross section of the part, and then uses heat lamps to fuse the plastic powder together. So this is like a little model I made. This model is showing the internal of the 3D printed skateboard, including the battery. So the battery comes out, it's like it's its own module. It's been printed with cells, 18650 cells actually, so lithium ion 18650s that go in this little case that was also printed on an HP 4200 machine, which is right behind me over here. If you would say like a home 3D printer is like a Toyota, and then you know Ultimaker is like a Mercedes, this is like the Rolls Royce of 3D printing essentially. Basically, this is the whole machine. It's huge. It probably weighs about 750 kilos, and it's huge. It's like 2 meters long or 1.5 meters long. And the way it works is it has this here, which is the print head assembly, and that moves along the x-axis left and right. This can print the entire cross-section of the bed or the build platform at once. This here is basically a heating lamp assembly. When it prints the black cross-sections in this powder bed area down here, once it prints them there, the heat lamps will turn on. The heat lamps will bring the black printed area above melting temperature and therefore fuse the powder together. So after you've printed the whole build volume, it gets taken out of this machine and then it gets wheeled over here. This is the unpacking machine. This machine is just dedicated to vacuuming up all the loose powder and recycling it. It's essentially a recycling station. So after the build volume gets put in here, we use this machine here and unpack the parts. So the way this machine works, it's got a vacuum hose here, which is used to suck up all the loose powder, and then it sends it into this tub over here for recycling. So the loose powder can get reused and loaded into the next build unit for printing again. It's been just removed from the powder in its fresh form. We chucked it in a sandblaster, which is just a regular sandblasting cabinet, although this has got like a ultra fine grit essentially. So the next step to the post-process would be washing it because it's still got sandblasting grit all over it. So if you follow me, we'll take it to the wash station. So we can put the part in there, close it up, open the water. And there we have it. So that's a Ruby Princess cruise ship printed on the HP Jet Fusion 4200 machine. So this is also an HP part, but it's black. I basically dyed it black. This is a non-dyed or part straight from the printer. It's a spring. And the way I designed this board was essentially to be thinner and lighter, that was my goal, than a regular like Wowgo or Meepo board. So you can see it measures at about 35mm thick, which is pretty thin considering like the cheap boards these days are like twice that almost at the thickest point, where they've got the battery compartment at the front and the ESC at the back. And And then I've also 3D printed some grommets to water seal the cables in. So the actual deck itself is printed in two parts. It's the front half, which is about the limit. I could just fit this part in, and then the back half was also printed at the same time, but obviously in two halves. And then I've connected them together with basically it's like a puzzle piece. So it slots together, and then there's 5 M8 bolts that are screwing it together. I've also made some slots as well on the side, showing the battery indicator, the power on button, and the charging port. So it's just a regular DC charger, just like any Meepo or Walgo. So basically when you push the board along the ground, when you get going, it automatically turns it on. You don't have to bend down and press the power button. I'm going to cut into some riding clips just so you can see how it goes right now. Alright guys, taking it outside. Gonna give it a test run in the real world. See how it goes. That's a real test of the board. So I just got back from my ride, and now I'm going to open it up to show you what's inside and how I've assembled it. It's got this little lid here, which not only holds the electronics in place, but it also kind of connects the two halves of the board together. That's just a little bit of added reinforcement, but there's also the carbon fiber rods in the side, as well as the 5 M8 bolts that are securing the two halves together. In here, we can see the ESC, the battery. It's just a standard Meepo V2 ESC, and the battery is pretty much just a repackaged Meepo battery. I've tried to secure everything pretty tight, so I've used zip ties, a bit of hot glue to make sure none of these connections are coming loose when we're riding. But actually I've realized it's not totally weatherproof because there's actually a bit of dust getting in here somewhere. So I'll also open up the battery so you can see how this. I'll probably integrate the battery into the actual deck itself, because that would even reduce the thickness further, because I've got essentially 4 layers of plastic: the base of the board, the base of the battery, and the batteries, and then the lid of the battery and the lid of the board. Underneath, that's the inside of the battery. So inside the battery, that's 20 18650 cells wired together with a regular BMS from the original battery that was provided with the old Meepo board I pulled apart. Also including a 3D printed stainless steel heatsink underneath, which helps cool down the ESC. And yeah. So that's the end of my build video. If you have any questions, please put it in the comments below. That is my fully 3D printed or mostly 3D printed electric skateboard build. Thanks for watching. I'm going to do more videos like this, project videos. So if you enjoyed learning about this 3D printed electric skateboard build, subscribe, hit the bell notifications as well, and I'll try and update with some new content.